All right, today we are going to do systems of equations. We haven't done this in a while. Two equations, two variables, three different ways we could do it. We could graph them. Probably maybe the simplest way to graph, but the least accurate. We can do substitution or we could do the elimination method. What I like to see is on this one, I'm going to write down one other example real quick. And then we will go solve both of these. I want to see A is, first off, is either equation solved for a specific variable, which in this case it is. So if that's the case and you have one that's solved for a letter already, substitution would probably work best. If not, if nothing solved for itself and X and Y are both on the same side, the elimination is going to be your best bet. So let's first do one with substitution and then we'll go over elimination. Since we have Y equal to something, we're going to take what it's equal to and replace it in the second equation. So in place of Y, we're going to put X plus 3. So in place of this Y, excuse me, X minus 3, not X plus 3. So we substituted in place of Y, we put what Y was equal to. So now we can combine like terms. We have two X's. So we have the equation 2x minus 3. We add 3. 2x equals 8. We divide by 2. X equals 4. So that gives us half of our answer. So to find what Y equals, we're going to substitute in 4 minus 3. What is 4 minus 3? 1. So our ordered pair is 4, 1. Remember what this is. This is a line, and this is a line. We're trying to figure out where do they cross on our graph, so that'll give us a point. Okay. So for elimination method, we want to look at, do we have two that are opposite, so exactly the same but opposite sign? In this case, we do. So we don't have to do anything besides add straight down because Y minus Y would go away. 5x plus 3x would give us 8x. 12 plus 4 would be 16. We divide by 8. X is going to equal 2. So we have half of it. Now we plug into either one. It does not matter. I'm going to choose this one because our Y is positive and we're trying to solve for Y. So we have 3 times 2. Place X with 2. 6 plus Y equals 4. We get rid of our 6 by subtracting. Y equals negative 2. So our ordered pair would then be 2, negative 2. We had one more kind with elimination that we want to look at. We'll do a couple examples of this. All right. So this one, we don't have any that are the same number but opposite signs, but we do have two that are opposite signs to start with. So we have 10 and with negative 5. Would it be possible to make this a negative 10? What could we multiply negative 5 by to get negative 10? 2. So if we multiply by 2, we have to multiply every single part by 2. So now we would get 8x minus 10y equals 46. So just like over here, we have same number and opposite signs. So we can go ahead and add. 3 plus 8 is 11x. These cancel, and we get 77. Divide by 11, x equals 7. We can go back to any of these three. We're looking for y. None of them are going to be the prettiest of numbers, but let's go with this one. 3 times 7 plus 10y equals 31. That's 21. So So we get rid of 21. 10 equals 10y, divide by 10, y equals 1. So our point would be 7 and 1. Okay. Let's do one more example. Again, none of the, when you work these three, you can do them any of the three methods you want, but the key is you've got to, whichever one you see first, they will give you the same answer. Which method you see first? Like this one, we could solve for A, we could solve for B. That's going to be more work. Right? So we could look at elimination. None of them are an immediate. We could not just multiply one equation by something. But could we get a common multiple for 3 and 5? Could be 15. We could do 36, but 15 is going to be a little bit smaller. So what could we get for this to be 15? 5. If we get 15 here, we want negative 15 here. So what would we multiply by? Negative 3. So let's multiply every single part. 15a plus 20b equals 10. Here we're going to distribute negative 3, negative 15a minus 27b, negative 3. Now they're opposite sign. That is what we want. Same number, opposite sign. So you cancel 20 minus 27, negative 7b. 10 minus 3 is 7. Divide by negative 7, b equals negative 1. All right, we're almost done with that one. So we need to find out what a is. Go back to either of them. 3a plus 4 times negative 7 equals 2. Or equals 2. Correct? Yes. 3a plus 3a minus 28 equals 2. Add 28. 3a equals 30. Divide by 3. A equals 10. So we could just write it, since it's not x, y, you don't have to write it as an ordered pair, but make sure you put both of them together, circle it, put a square or something. If it's x and y, generally it's most accepted to write it as the ordered pair. Okay. All right, so what I want to do today on the same page from Friday, solving equations and systems of equations. We look at 49 through 53 on solving equations and systems of equations. Same page we've been working on the last couple days.